I added some install instructions for Stonks before I make a proper release, and it has one step: create a virtual environment. In this video we will learn about virtualenv and 3 reasons for using it. To understand the problems a virtual environment can solve, we must understand what packages are and how Python handles these. Packages are super useful because you can download and install libraries and other software from a repository, just like RPM for Fedora and Red Hat, Homebrew for macOS, venv for Java, npm for Node.js and JavaScript, and Go modules. Python packages provide reusable software components and libraries, so you don't have to write them, like pandas, numpy, and many others. The Python standard library is rich, but not everything is available there. For example, I plan to add some cool charts to Stonks. However, the standard library can't draw charts, but third-party libraries like matplotlib and plotly can. Technically, we could draw everything with a canvas, but why would we do that if there are multiple perfectly working libraries for the task? So we download 1, 2, or many libraries because that's what experimenting is about. Those packages will also depend on some other packages, so a lot more will be installed. We will end up with a ton of unused packages installed. For example, I mentioned plotly because it's a really cool plotting package, but it doesn't support the GUI framework I will use in the project later. Can I remove it? Maybe, but if I use my main Python, removing seemingly unused packages can cause some dependency problems because some other apps may still need it. So if I create a separate Python bundle for each project I'm working on, I can avoid spamming my main Python with unused packages. And if things get messy, deleting and recreating a virtual environment is super easy. Let's start by making one in VS Code. Just navigate to your project root and type python-m venv.venv. If VS Code asks if we want to use it, of course say yes. The venv is the virtual environment module that creates virtual environments, and the .venv is the folder for our brand new and clean Python bundle. It's like a clean install. No packages will be downloaded automatically, not even pip will be updated. If you never used virtual environments before, on first run you may encounter some problems. For example, on Windows it's blocked by default and you have to enable it with a command. Now, if the .venv is shown in the terminal, you are using your brand new Python bundle. Let's check out the second reason for virtual environments: pip freeze. This command will list all the installed packages. This is useful if you don't want to guess what packages you want to use with your project. The related command is pip freeze to requirements.txt, which dumps all the installed package names and versions in a file. The requirements is the common name for this. With this file, you can tell pip to install all the required packages without typing long list. So, if you work with separate virtual environments, you can generate a requirements file for each project. This is important because you may have several projects at the same time. I have one including Flask and Fast API, had to do some data scraping with Scrapy, some work-related stuff, and many more. No one wants to install unrelated packages. It may take some extra time and space, but there's a special case where you must use a specific version of a package. Backward compatibility is a nice thing, but sometimes breaking changes are introduced to a package. Even worse, 2 projects may require different versions of the same package. It would be almost impossible to solve this without virtual environments, but trivial if you create a separate virtual environment for both projects and install the different package versions where they are needed. One last thing to mention: there is a reason why .venv is a hidden folder by default. If you use version control, and I really hope you are using one, you must not include this .venv folder. For example, GitHub's default Python gitignore file has .venv listed, so if you follow the naming conventions, you are good to go. Everyone should maintain their own virtual environment, because people may use a different operating system or architecture. If someone would push their .venv folder to a repo, it would break many people's work, and the usual "it just works on my machine" excuse doesn't work. Don't be that guy. I hope now you understand the importance of virtual environments and start using it. Thank you for watching, and see you in the next episode.